thank you for joining in your evening or morning, wherever you are, for this KNIME webinar on XAI. My name is Paolo Tamagnini. I'm a data scientist in the evangelism team, but today it's not me presenting. It's going to be Keith McCormick from connecting from Boston, correct?
I was in Boston recently, including some posts on LinkedIn, but I live in Raleigh, Durham, North Carolina.
Okay, North Carolina. And yeah, Keith is a great educator from LinkedIn Learning. He has been doing many KNIME courses there. And when we released some time ago those XAI components, as well as those XAI nodes the KNIME offers, Keith created this amazing course on how to basically explain machine learning models in KNIME. And there we are. We created this, we basically booked this webinar. And I won't take more of your time. Please just, if you have any question, use the Q&A session here in Zoom. So basically to post any question to Keith, and some of them I will answer them right away, but for the best one, I'll keep them for Keith at the end of the presentation.
Okay,
all right,
thanks,
Keith, did I miss anything?
No, that's perfect. So everybody, I'll tell you just thanks again, Paolo. I'll tell you just a little bit more about myself to kind of put this into context. In addition to the LinkedIn Learning courses, I also do some teaching for UC Irvine. And I've used a lot of predictive analytics tools over the years. I've been doing this since the 90s, but I discovered KNIME several years ago because I really needed an open source tool. I had been using some commercial tools, and that was posing a bit of a problem for my UC Irvine classes, because we really wanted something that was open source, but that was also low code, no code. So that's the quick version of how I got introduced to KNIME. And XAI has been a hot topic for quite a while. So as Paolo mentioned, both KNIME and myself were very fortunate by the timing, because I had absolutely intended on doing an XAI course, but when I discovered how well supported it was in KNIME, it was just a perfect fit. So we'll dive right in. Now, I'm going to keep things pretty basic today for a couple of reasons. I have much less time than my LinkedIn Learning course, which runs a couple of hours. We've set aside about 45 minutes to present. And when you're doing things live, be patient with me. I've got several windows open. It's all for a reason, because I don't want you to have to sit there waiting for something to execute. But that also means if a window closes on me and I have to rerun it, there'll be brief pauses and so on. But fingers crossed, we won't have to worry about any of that. So let's jump in, and I want to do a few minutes of slides. I want to lay a good foundation here. Also, I'm assuming a mixed audience. Feel free to introduce yourselves in chat, and the team will check that out. But I'm assuming that some of you are new to KNIME, many of you probably are not, and some of you are brand new to XAI, and there could be all kinds of combinations there. So let's see. So here's the goals, and I'm going to try to get all this done in the limited amount of time that I have. So opening topic that I want to talk about is I want to compare interpretable machine learning and explainable AI. Now, you've got to be careful, because not everybody uses these phrases exactly the same way, but I studied the heck out of this when I was putting together the course, and there's a growing consensus about what these mean, and I'll have more to say about that in a minute. The other thing that I want to do is that I want to make a general assumption that your KNIME learning is not over. So even if you're an expert user, there's new stuff coming out all the time. So I've developed an approach that I find works very well when folks are new to a particular set of new nodes or a set of new features. For instance, maybe you're not new to KNIME, but you're new to the XAI functionality. So I want to tell you a little bit about that. And that comes directly out of my experience at UC Irvine, not just as an instructor, but as a grader of homework. So I've seen where people have solutions that kind of go off the rails, or they get lost and they get frustrated. And KNIME, as I'm sure most of you will agree, is very easy to learn. Those of you that have had the opportunity to spend some time in there, it's actually quite easy to learn. So I've determined that there's a couple of reasons why when people get a bit frustrated learning something new, why that happens, and we can prevent that just by a couple of very straightforward steps. Then, and this is going to be important to our presentation, we don't have a ton of time, but we are going to be talking about both global and local explanations. So I'm going to be commenting on what that is, and then we're going to see somewhat different functionality for the two, which is going to include the demo that's mentioned here. A couple of things that I'm not going to get into, there's just not time. Computer vision, for instance, didn't even fit in the longer course, but you will encounter, if you go out into the world and you're looking for articles and videos on social media and so on about XAI, you'll often find that it's trying to figure out the salient part of an image that caused a predictive model to recognize something. The classic, is this a cat or is it a dog type thing. That is something relevant to XAI, but it's a completely different area, and we won't be touching upon that at all. So just a little truth in advertising there. We also won't get into deployment. So we're going to be using this in an exploratory way, there's going to be no kind of ML ops aspect to this. However, if you're generating reason codes for a financial institution, that's a topic that would be of interest to you. We just won't have time to get into any of that today. So key points again is going to be, what's this interpretable machine learning explainable AI distinction? And then what's this global local distinction? And then taking that global local distinction into the demo. So explainable AI has as its premise that there's something about your model that is difficult to understand. Now, in using the KNIME functions, I actually think that some of these functions could be really great, even if you're using an algorithm that produces transparent models. I actually think it can still be useful there, but primarily when we think of explainable AI, it's because something has to be explained. So presumably it's black box, and I'll have a bit more to say about that. Now, this is where you don't have complete consensus, but a growing consensus. There was a cover page article, an Association of Computing Machinery, for instance, and I've seen countless lectures on this topic at this point. And there's somewhat of a growing consensus that interpretable machine learning is when you're building a transparent model from the start. So to keep it very simple, that could be one decision tree. Now, I know that for some of you, that sounds incredibly old school, but there are reasons why you might still want to go that route. You don't want to eliminate that as a possibility. So it would also include things like linear regression. And again, you may be thinking CART, regression. These are techniques that have been around for a long, long time. I want to be using something more like Random Forest or XGBoost. Well, when you do, you lose that transparency, don't you? So XAI is putting a modeling layer on top of your black box layer to explain what the black box model is doing, since you can't get at that explanation directly. That's the distinction. Choosing an algorithm that's by its nature transparent, or choosing an algorithm that by its nature is opaque, and then by implication, having an extra step of explaining that black box model. All right. So some things to think about that might prompt you to have this need. Well, and notice that the first two bullets are not the same thing. So you might be worried about if you even understand why your model is making the predictions that it is. So for instance, we're going to be drawing upon a data set that the KNIME team themselves use in a number of blog posts and demonstration workflows about creditworthiness. And you might want to know, what are the key drivers of creditworthiness? As it turns out, we've already started talking about what global explanations are, because global explanations are at the model level. On the other hand, it might be the case that someone, let's just call them Bob, randomly choosing a name out of thin air. Bob just applied for a loan, and got turned down. And the number one reason in the model is late pay, but Bob doesn't have any late pays. So now you have an interesting question. Why did Bob get turned down if he didn't get turned down for one of the top 3 variables? It must have been some unique combination of less important variables that nonetheless deem Bob not creditworthy. And now you're in a totally different area. This is like when you get letters from a lender when maybe you applied for an increased credit line or a lower interest rate or what have you. And particularly if you're in the US, there's a very specific set of laws related to this, and you get a letter in the mail and it says that you have been declined for reasons 36 and 81, reason codes. Well, that's also related to explainable AI, but that would be a local explanation. So key drivers would be a global explanation. This specific individual prediction aspect would be a local explanation. Other reasons why XAI might be on your mind is that the model is high stakes. You might have to explain not only to senior management within your own organization, but there could be a situation someday where you have to explain this stuff to a jury. You might be regulated. Insurance, for instance, insurance regulations differ across around the world, but here in the US, each of the 50 states has a commissioner of insurance that companies have to go to if they are going to operate within their own state. Insurance clients that I've worked with over the years tell me that one of the challenges is that the 50 states don't have exactly the same rules, and that actually makes things very complicated. I am going to urge you, though, right off the bat, to try a transparent model first. And increasingly, when I'm meeting data scientists that have just joined the field that come to me, let's say during a conference workshop and ask for my advice, increasingly, this doesn't seem to be advice that everybody embraces, or maybe they just haven't thought about it. To me, it's just kind of the way that I was trained, and I think it's so important. But try the transparent model first so that you get some indication going into the more complex model of whether or not you're getting the explanations that accurate explanations and explanations that are going to be helpful. So I always urge you to do that. So we're here to talk about XAI, but that doesn't mean that if you deploy XAI, you can't, during the data understanding phase of the project and the modeling phase of the project, also try an interpretable machine learning model. There's a couple of reasons why this is a particularly hot topic now. I think we can recognize some of the reasons. So complex models are on the rise. Now, there's always been this interplay between complex models and simpler models and the trade-offs. You know, we hear about the bias variance trade-offs, and this has been described by many different authors in many different ways. But let's face it, deep learning is dominant right now. If you're starting out in the field, no one, when I was starting out in the 90s, deep learning wasn't a thing. Neural nets were, but not deep learning. So it's not something that everybody knew. Now everybody knows that. And a lot of times people try deep learning first. Well, deep learning, XGBoost, Random Forest, all the hot algorithms are going to generate opaque models. And that's why some of the things we're going to be talking about today, for instance, they're less than 5 years old, which is pretty remarkable when there's so many things in machine learning that have been around for a long time. Even deep learning is substantially older than 5 years now, but things like LIME and CHAP, a couple of things that we're going to mention briefly, are younger than that, okay? And then we mentioned reason codes already. And then another one, which I think is really interesting, is debugging. So I've got a quick quote to share with you. You might not recognize this gentleman's name, but he came up with LIME, which is one of the main techniques. And KNIME has implemented something LIME-like, which you're going to see in my demo. But what he was... Oh, very sorry about the background noise there. All right. So he was working on some modeling. He happened to be, I believe he was doing computer vision, actually. But what was happening was he was building a model that looked great during training and validation, for that matter. He was doing holdout validation. He's a real pro. He was doing this as his PhD work, or just after. But it was generalizing terribly when he tried to deploy it, and it was driving him crazy. He actually developed LIME out of frustration for not having a good way to debug what was going wrong with his model. And if you mention here, it's one of the classic reasons is that the model was picking up on not just what it should have been picking up on, but an artifact of the data processing step. And it was an interesting example. I encourage you to Google it and try to find his discussion of this. So I want to briefly get back to this this business that we build complex models because they're more accurate. And there's a lot of truth to that, obviously. This is something I spend several minutes on in the course that I can only spend about 1 minute on here. But this is a famous chart out of Hasty Tibshirani's very well-known text. And what they're talking about here is that generally, as you have less interpretability, they don't use the word accuracy, they use the word flexibility, which is a little bit different, but certainly it's related there. And this basic idea that if you're going to use something like deep learning or XGBoost, it's going to be more flexible, but less interpretable. And if you're using something like linear regression, logistic regression, or a single cart tree, you're going to have greater interpretability, but you lose some of that flexibility. So the notion is that when you lose that flexibility, you lose the accuracy as well. So a lot of folks say, well, the heck with the less flexible stuff. I'm just going to jump right in and I'm going to do the opaque stuff right away. And I've already suggested to you that maybe you don't dive in that quickly. So another thought leader that I recommend here, and she's got very strong opinions about this, with which you may or may not agree, but she makes a strong case, and all I would ask is that maybe you seek her out and learn a little bit more about the argument that she makes. But she makes the argument that there are probably times that we go with a more complicated model when we could have used a less complicated model. To put that in language that we've been using today, a lot of folks jump right to a opaque model that's going to require explainable AI when possibly they could have gone the interpretable machine learning route. So here we go. It's time to get into KNIME, certainly, and we're going to spend the bulk of our remaining time in KNIME. But I want to start with this general advice about how to learn something new in KNIME. I urge you to find an existing workflow. The example server is a great place to go there, but as we're going to see, it's not the only place. And then spend some time with it. This second bullet is what I discover that the students that I've had at UC Irvine, and when I'm grading their homework, when they run into trouble, it's usually because they've skipped this step. What they do is they take the existing workflow that's running because they've downloaded it from the team at KNIME. And then they immediately do surgery on the sample workflow because we all figure, hey, we're coders. This is low code, no code. It's even easier than coding. I'm just going to jump in and I'm going to start making changes right away. I urge you not to do that. As little as 15 or 20 minutes playing around with the existing workflow to get familiar with it makes all the difference. Then swap out the data set, then get it working again. And getting it working again might take several minutes because there are a couple of things that maybe you haven't thought of, like having to declare the target variable, or maybe you have a scale variable that should be declared as a string or vice versa, okay? So it's very simple, and I'm going to demonstrate that now. Oh, so here are the 4 places to look, though. I mentioned example server already. You can also search for a node. I'll show you where that is. There's also the hub, and there's this hub interface that's been added to KNIME itself fairly recently, which is great. But then also the blog. If you get, now naturally, there's going to be more support at the node level or in the example server because that's accumulated over a great deal of time. But if you get lucky and there is a blog post that gives you citations and discussion and explanation and workflows, you're going to be all set. And as it turns out, there is a blog post with all of that supporting material for local and for global, which is great. All right. And this will return to at the end. So again, I apologize for all the windows here, but I didn't want to have to launch anything while we were live to save time. So this is what you would be greeted with when you get in KNIME. And as for the resources that I was just talking about, I'm actually going to bear with me for a second, I'm going to drag the chat and the Q&A out of my way so that it's on my other monitor. Almost done with that, just a second. We've got plenty of time for questions, but I usually can't resist taking a quick look. Okay. So this is what you'd be greeted with if you happen to be new for KNIME. But here's the example server that I was referring to. You can just double click on there, for instance. Takes just a moment for that to launch. And I'll give you an example of what I mean. So for instance, if you go to analytics, and we're going to keep it really simple because we're only going to spend about 2 minutes on this. If you go into analytics and classification and predictive modeling, for instance, there's an example for learning a decision tree. So to remind you what I'm about to do is I just want to very briskly show you the 4 steps that we were just talking about in the slides. So here's an existing example. And if you right click on the table, oh, bear with me, let me zoom in. Usually I can fit 125 without much trouble. So if you right click and take a look at the table. Oh, I haven't run it yet, that's why. But with these existing examples, you don't have to worry about finding the data sets because they're going to be referenced directly by the by the workflow. And you can see that this is a multi-class classification problem. If you look at the final variable, which is the target variable, you can see class 1, class 3, class 0. And that would be a tricky example to do as a demonstration. The credit example is a lot better. But again, if you follow the advice that I was giving, what you want to do is spend some time in here. So you get a little bit familiar with, for instance, the holdout partitioning. How is that being done? And get familiar with that before you switch data sets, because you might have to change the settings. And the decision tree learner, for instance, you might want to get familiar with the settings in there, because again, you might want to change those. Okay. And what I've done is I've got an example of how I took something extremely similar. Let me show them back to back there. You can just kind of count nodes and take a quick look. I've got a table, I've got partitioning, I've got the learner, I've got the predictor, I've got the scorer. So what have I added? I've only made modest changes to it. I've got an equal size sampling node in there. And that really is the approach that I recommend, is take something very simple. And there are examples at the individual node level in support of XAI. We're not going to be doing those examples today. We're going to use the global and local views, they're called. But when you're learning one of these new features, that's exactly what I would do, is I would grab the existing example, I would get familiar with it, I would swap out the data set. In this case, we're switching to the credit data set. I'm going to maximize that. I know the font is probably really small, but it's going to be, our target variable is going to be serious delinquency within the last 2 years. So I've swapped that out and made probably a half dozen changes, not changes that I'll walk you through or demonstrate now, but a half dozen changes. But the familiarity that you get looking at the stock example allows you to make that without too much difficulty. Okay. But the example server and the hub, which you can access from here as well as searching for relevant nodes, are not the only resources you've got. You've also got the blog. And again, as I've said, if you get lucky, you're really going to be in good shape, because notice that there are 2 blog posts. And I would suggest that you just make brief note of this. And Paolo, I'm sure you could put the links to these 2 in the chat, which would be fabulous. But here are 2 specifically where I got workflows. So this one is called Finding Counterfactual Explanations in Local Feature Importance. So this is going to be talking about local. And then notice there's an icon over here where you can either drag and drop the workflow that you see onto KNIME and automatically load it. And that only takes about a minute. But I want to caution you about something, and this is why I loaded these in advance. You don't want to forget about the extensions. You, for instance, perhaps don't have one of the nodes that you need to run this workflow. KNIME makes it very easy. It will warn you that you need to do that. But if I were doing the drag and drop live, you would see that in some cases, I might have to update nodes, and that all can take a couple of minutes, right? But KNIME makes that easy. You can, of course, also download it and then load it, but the drag and drop can be very handy if you've got a big enough workspace. The other one that we're going to be doing today is the workflow in Compute and Visualize Global Feature Importance Matrix. Now, the relevant nodes are going to be the Global Feature Importance view, and then back on the local one, the local explanation view. And the reason that works so well for a presentation as brief as today's is the KNIME team has packaged more than one global and local feature within these views. So it makes it very simple. Go back now to KNIME. So let's take a look. Oh, that's the one we were looking at a moment ago. Here's the local, but I want to start with the global. Here we go. Let's zoom in a little bit. Anybody want to just quickly comment verbally on the size of that? How are we doing? How legible is it? Actually, I just went up to 150, so I think
we can see pretty well. You keep going.
Sounds good. Okay. No, it's just zooming in. And those of you that ever have to present a KNIME workflow, depending on the resolution on your screen, 100% might seem small on the other side. For instance, I don't know if any of you are trying to look at this on a tablet or a phone, perhaps, right? But zooming into 125 or 150 is can be very helpful. Okay, so we already looked a bit at the data set. And to orient you a little bit to the partitioning, again, it's always a good idea before you start looking at things to get a little bit of an idea of what's going on. We are using they're stratifying this on the target variable credit worthiness so that we have it balanced going in, and we're letting the AutoML decide what model is going to be built. So naturally, we're going to be throwing some of the complex algorithms at that. So we're going to end up with an opaque model. Remember what global feature importance is. It's looking at the model as a whole. So there's several approaches to this, but we're going to be looking at those that are supported in the global feature importance view, surrogate models being one of them. Actually, I already have this open. If I were to do that again, it would launch it again. So here is global. This might be perhaps a little bit tougher to read. It's actually a great report when you're looking at it natively, but I'm going to walk you through what all of this is. So it's actually using one approach in 3 different ways, and then using a second approach as well. So let's start with the notion of a surrogate model. So what's going on with a surrogate model is it's almost like you're doing interpretable machine learning and explainable AI at the same time. You're starting with your opaque model, and the reason that you're starting with an opaque model is that you concluded to get the performance that you need you're going to use that opaque model. However, you can often build a transparent model that is a pretty accurate proxy of the opaque model using a transparent technique. We'll come back to GLM in a moment, but I think the one that's easiest to visualize is building a surrogate decision tree. So let me clarify something that's super, super important to understand. And if you understand this, you really understand what we're trying to do with a surrogate. We're not building a decision tree on creditworthiness in lieu of a black box model on creditworthiness. If that was the case, we should just go ahead and do interpretable machine learning. What we're doing instead is we're building a decision tree where the target variable is the prediction of the opaque model. So we're trying to look inside the black box. So if you take a look at this, notice, and by the way, accuracy is not the default setting. There's a different default setting in this node, but I made that one change to it. Otherwise, I'm running on defaults. You have this very high accuracy of 97.5%. If you're anything like me, when you get near 100% accuracy, you start to worry that it's overfit. But it's not overfit because our target variable is not creditworthiness. Our target variable is the opaque model's propensity score, basically. That's the key point in understanding surrogates. And before KNIME went through the trouble of making this very, very convenient, the way that you would sometimes build a surrogate, and I've been doing this for quite a few years, so I've been doing surrogates for 20 years probably, but I never had a tool like this. What I would have to do is take the predictions of the opaque model, make it my target, and actually go through the model building steps. It wasn't automated like this. So this is really convenient. In addition to a surrogate decision tree, the global view also gives us random forest and GLM, but they're all doing the same thing. They have the target variable of what the opaque model said. And now what you're able to do is to come up with a proxy model that is transparent, and then you look to see what the top variables are. And obviously having a consensus across multiple techniques is not guaranteed, but it's kind of nice when you do have that. I don't know why the webcam is from above when I'm looking right at it. I think that Zoom is confused about which webcam I've got here. I don't know if it, I'm probably just a tiny thumbnail, so I don't think anybody's distracted by it, but I think the wrong webcam is gone. Nonetheless, what I want to do then is just repeat that last point, that it's not a guarantee that you're going to get a consensus across the 3 surrogate models, but when you do get that consensus, obviously it gives you confidence that you really have identified the top predictors. And when there's a difference, you really have to kind of reflect a bit on the differences between GLM, decision tree, and random forest, and that might give you some ideas of where you might get some differences. But let's see if we have consensus or differences here. So our top variable, according to the GLM, is times in debt for 3 months, times in debt for 3 months or more. The top variable, according to the surrogate decision tree, is a similar, it's not identical variable, but it's a similar one. It's times in debt for 1 to 2 months. And naturally, you're going to have a high correlation there. And according to the random forest, the top variable is times in debt for 1 to 2 months. Now, of these 3, I'll be curious when we get to Q&A if Powell has a different thought than me. But of these 3, the one that I'm the most drawn to, naturally, I love being able to see the surrogate decision tree, the single tree, right? But in terms of the greatest confidence in the ranking, I find the random forest really appealing, because the way that random forest works is it tries to mix up the variables. So when you get a variable like debt ratio or family size, or actually even monthly income, right? Monthly income all by itself doesn't seem to help as much as some of these others. But when you look at debt ratio and family size, and you're doing, let's say, 1,000 trees, and it's consistently a weak performer, you start to think about, wow, well, if I maybe there are variables that I can safely drop if consistently they're not needed. This is a data set with only about a dozen variables, so I don't think I'm dropping variables at all. But if I had 150 predictors and I had some very weak performers and 1,000 trees, that tells me that if there's any fear whatsoever that I'm overfit in my complex model, maybe I can consider dropping some variables and doing a little bit of variable reduction. And you know, the things that I've been talking about for the last couple of minutes is one of the reasons that I think you should consider using, I mean, this is so easy to use. Consider running a report like this, even when you're running a transparent model. It really has been designed to do XAI, but that doesn't mean that if you're running a single cart with 60 variables in it, that it wouldn't be really interesting to do this, because you get into this gray area when you have a very large single tree, where in theory it's transparent, but in practice, it's not really super transparent, right? So I wouldn't bring this out only when you're doing Random Forest or XGBoost. I would consider doing it too when you have a simpler model, but maybe the sheer number of variables is starting to make it a bit complex. Now, permutation feature importance is another one. And it's actually really, really interesting. So what happens here is there's something that's supported in KNIME. That's a concept that a lot of folks are not familiar with. It's called target shuffling. And what it is, it's when you randomize a variable. And you might think, goodness sakes, why on earth would you randomize a variable? That's going to screw up the correlation. Well, that's the whole point. So what we do is we take one of our independent variables, one at a time, we shuffle it so that it loses the relationship with the target variable. Now, the reason you do this is when you shuffle a variable and you make it, you put it in a random order, the correlation does not become zero exactly. It doesn't become zero exactly with the target variable, and it doesn't become zero exactly with the other variables either. What's happening is you're disrupting that relationship, but you're keeping the model largely intact. So the number of variables are the same. There's a lot of things about the model that's the same, but this one variable has been altered. Well, then you look at how much performance drops when you alter, when you shake up or shuffle this one variable. And if it's a really, really important variable, your performance will drop a lot. And if it's a not so important variable at all, performance isn't going to change. So we see that times in debt for 1 to 2 months, a variable that we've already been talking about for a few minutes now, does cause performance to drop when it is shuffled. But age does not cause performance to drop when it is shuffled. So very interesting stuff. Now, those aren't the only global explanation approaches supported in KNIME, but they are the ones in the global view. And if you're new at XAI, I really urge you to start there. So I'm going to minimize that. And now we're going to go to local. And after we talk about local, we're going to switch over to our Q&A. Okay, so what's interesting about local, of course, is that since we're doing local, we're talking about an individual case. And since we're talking about an individual case, we have that individual case right here where we can look. So this particular case, and I'm going to show you in the workflow where this is done in a moment, but the particular case that was grabbed by the node to look at, remember that this would be, when we're doing local, we're talking about things like reason code. So we want to know why Bob Smith, made up name, why Bob Smith was turned down for the loan. So it turns out Bob is 46 years old. That times in debt for 1 to 2 month variable that we've learned is really, really important is 1. Bob happens to have a big family. He's got some other real estate loans. Actually, the time's in debt for 3 months. The similar variable that happened to pop on the GLM surrogate is 0 for him, but he was late once for 1 to 2 months. So he has been deemed risky, okay? Well, take a look. He does have a value greater than 0 for times in debt for 1 to 2 months. So in this particular instance, this person that I've arbitrarily named Bob is greater than 0 in this, and this is bringing his creditworthiness down according to the model. But notice that this isn't a key driver analysis. This is specific to him, okay? So if notice that times in debt for 3 months or more is neutral for Bob. Well, it wouldn't be neutral if he was 1 or more. That would be a red bar in that case, right? That's the difference between this and global. And then in terms of debt ratio, his debt ratio apparently is fine, because if he didn't have the lateness based upon debt ratio and age, he's in the green, okay? So that brings us to counterfactuals. And I'm actually gonna maximize this so it'll be a little bit bigger. And what counterfactuals are is 5 neighbors, if you're familiar with the notion of nearest neighbors. It's 5 cases that are similar to Bob. They're not identical, because if they were identical, they would get the same score, but they're similar. They're, you know, in cluster analysis terms, they're proximate, right? But these 5 have all been deemed creditworthy, and that's why they're counterfactuals. So this would give us some indication of how much work Bob has to get from risky to creditworthy. And we find that in all 3 instances, there were 3 more, but I'd have to back out, click on next, and go back in. So we're just going to look at the 3. All of them have times in debt 1 to 2 months of 0. But we can look at some of these other characteristics as well. But it seems like that really was the tipping factor. So that's not something you can change right away, like a balance. He might have to wait until that drops off his credit or something, something like that. There are people who are experts in that kind of thing, but that seems like it's the deciding factor. Let me show you where in the local workflow, I think it's here. Let me zoom in. Let me show you where in the local workflow that case was chosen. Actually, you know what I'm going to do? I wasn't sure I was going to have time to do this. I want to point you in the right direction for this. What we can, I went in as if I'm configuring it. This will take a moment to come up, I think. The easiest way to change it would be if we use the box select tool and grab somebody other than Bob. And notice that cases come up with those particular characteristics. This individual, did I manage to choose Bob? It looks awfully similar. Family size of 7. Oh gosh, look at that. I could choose a different case here. There we go. Now they're 39. Oh, and this individual has times in debt for 1 to 2 months of 0. But then I can go down to close and apply, and that would give me a different individual. I'm not going to run that now because I want to go back to, forgive all the open windows, everybody, but that was the only way to do this efficiently. And we're pretty much on time for Q&A here. We can actually hold off on this information until later. So let me stop sharing, at least for now. And where do we stand with, perhaps Paolo, you could come on audio. What are we looking at for questions?
Hello. Yeah, thank you, Keith. Amazing presentation. I was trying to listen, of course, as much as possible, but I was busy reading all the questions. So
Oh yeah.
really great presentation. Thank you also for the live demos. Imagine, guys, that we have many webinars, but doing the live demos and showing in practice, not just with screenshots, it's always tricky. So thank you, Keith, a lot for going there into the details. Was really showing the capabilities of what those components do, what those interactive views, feeding in the model. So we have a few questions, right? So some of them maybe lack a bit of context, but there is one that I think it's quite interesting from Dr. Vladimir Andre Gimenez Rivera. He's asking, regarding the surrogate models, right? We have those surrogate model where you can actually retrieve the features that appear important in there and rates the opaque model to see if the prediction capability is affected, right? So what he's trying to say is basically that once you see the features in the surrogate models, you can use the information to retrain the model and see whether the surrogate model based on those new prediction is changing or not, right? If it doesn't change, of course it would be scary, right? But of course that also means what kind of features you provided to these surrogate models. If you remove it, right? Like, what do you think, Keith? Did you get the question?
Well, it's giving me a slightly different, idea, I think. And that is, first of all, I love the idea of experimenting. I think we don't experiment enough, because we have tools that are so easy to use now, like AutoML, that we tend to do a single big experiment, with a bunch of algorithms, and then think, well, that's as good as it's going to get because this one algorithm floated to the top and then we're done. So this idea of actually doing a model, looking at the results that we got, and then maybe even going back to data prep. Maybe we looking at the features, we started to think, wow, debt ratio is not working. Maybe I need change in debt ratio. Maybe I need delta in debt ratio. So I love the idea of experimenting, but I think I would have a different approach. I think if
it's like I think that what is mentioned is like, I mean, it's all correct, right? Experimenting and so on, but it's like saying surrogate models is an exact technique. Exact technique is about taking a model that is trained, that we want to explain because we like it and it's time to explain it. But it's like saying surrogate model could also be used as a technique for feature selection, right? Like, which is a different kind of problem altogether, right? It's like trying to select in different, which is true, I guess, right? Those XAI techniques could also be used for other techniques, right?
Well, but again, that's where I think what I would do is, that's what I really love about the random forest on the global side, is that it's iterating through lots of different combinations of variables. And I do think that if consistently they're performing weakly in the random forest surrogate, you can consider dropping them, right? Now, this is where my brain takes me, right? So the basic premise I like a lot, right? But where my brain takes me is that possibly you thought you couldn't do interpretable machine learning because you had 110 inputs, but now you've removed 62 of those inputs. You've cut your inputs in half. I would try interpretable machine learning again, because possibly you might suddenly find that you get a smaller delta now between maybe the added accuracy that you were getting from opaque was mostly coming from noise. So I would go back to the very beginning and revisit whether or not to do IML or XAI, and maybe after doing some data reduction, you actually can build an IML model that's pretty good.
Thank you. I think that's enough. We have also many questions, but I agree with you. Yeah. So
I would invite a follow-up, though, even if we can't address it live today. I would invite a follow-up on.
Yeah. So possibly maybe also, I mean, you can find us also on LinkedIn, right? So we can chat some more. So there is Victor Palacios. that is asking, so have you used the built-in feature importance in the random forest node? I was wondering if you think these are reliable as permutation feature importance, for instance. But I guess maybe like a point is like, it looks like that this, the Victor is using the random forest learner, right? So it means that he has already some tools given that he wants to use the random forest learner, not just any model, right? And that node already offers some information as an output. So maybe that's the point. So what do you think? Like, it's like, instead of using a black box approach, it's like considering, hey, here is the random forest node. Maybe I can, given that I know it's random forest, using its unique features to explain it.
I'm attracted to the idea of using both. I'm curious to hear what you think, but you know, they're not the same, because if you do it, if you do the feature importance right in the random forest node, your target variable is the actual target. Whereas if you're doing it in the global view, your target is now different. Your target is the prediction of the opaque model. So I like the idea of doing both.
I think too, like, I mean, in the end, it's all about experimenting, having hypothesis and testing it. My opinion is also that sometimes those techniques you can ignore what models you train and just use them all and see what are the ones that are working for you, right? But sometimes it's also good to know which models you're training. And like we said, if it is random forest, maybe you can also go right there and without training any other surrogate random forest, just go inside and look at these weights. But
I've always had a rule of thumb when I've talked about this rule of thumb, sometimes people will push back because they're going to want to know what the 3 is. But I think of it, you know, in like American baseball terms, like 3 strikes, you're out. That I'm reluctant to drop a variable during data reduction for one reason. So again, people want to know, well, what are the 3 reasons? It's very contextual to the project. But if the built-in feature importance said to drop a variable, I would hate to think that I would drop a variable and never consider that variable again, because there could be a number of things that were at play, like did I balance the target, or had I not balanced the target yet, or something. So I'm always reluctant to drop a variable for only one reason. So that's another perhaps motivation to run it right in the random forest node as well as in the global view, is that you're accumulating evidence that a variable is safe to discard. Because discarding a variable is a big deal. You spent time and money acquiring it, cleaning it, sitting in meetings, deciding that it was in, right? So discarding a variable is a really big deal. So I want more than one reason. I don't have some laundry list to share, but I want more than one reason to discard a variable, because I think discarding a variable is a big step.
I agree. Let's see. Okay, so we have maybe one other question. Let's see here. So we have Carles Torres answering live. Can the relevance of different features calculated in the interactive column filter component be related to the output of the global feature importance component or the XAI view component? So he's using another component that maybe was not part of your course, Keith. It's called the interactive column filter component, which gives you an option to move a slider and remove certain columns, whether because they have too many missing values or too many constants values, too many unique values. And he's asking, instead of simply using that component to filter away columns, you can also combine this component with the XAI approach, right? Where you are looking later at those features. I mean, like, I don't know, do you have an opinion there? I think that's, again, like using the XAI components, not just to explain a model, but for also different purposes. Before we're talking feature selection, here's like cleaning the data in itself. Like, I mean, it feels a bit overkill in this case, but I guess that could also be like bad quality columns would also appear in XAI if they were not taken out earlier in the process, right?
Well, I have a follow-up question to Carlos himself. If Carlos, if you're actively in the chat and you can type this, were you asking that in the spirit of strategy or logistics? were you thinking that if you had a bunch of variables and you identified some of them as weaker, is that you were trying to do that as like a point and click shortcut or as a strategy thing?
Let's see, he needs to make another question in the Q&A in order to answer us. So maybe
because I suspect that it might be the latter, or at least I might ask that. In fact, in that spirit, shortcut maybe. Okay, yeah. So let's say you had 100 predictors and your, that's going to, reports start to get challenging to read when you have a whole bunch. But if you did, what would be the easiest way to take what you've learned in like a view? Would there be a shortcut there that you can think of?
Maybe while Carlos is thinking about it.
Well, he said shortcut maybe was his reply. Okay.
Right. So maybe that's okay. It's like changing from Q&A to us to Q&A to
Yeah.
Okay, but yeah, I think it's also nice. Maybe next time we can open the chat and unless things it's already overcrowded here.
Yeah, there's a question about like the computer vision side of things. Maybe on the KNIME side, you guys could just say that maybe that will be in a future blog post or something at some point down the way. Is anything like that planned? Talking about XAI on the computer vision side.
Yeah, so I don't know if you guys noticed, but there is the big release that came out last June on the Python node side, right? So of course, Python open source library are many, and they already offer many solutions. They are open source and free. The KNIME could integrate now much more easily. So I wouldn't be surprised at all if you would be able to explain a TensorFlow model or a Keras model, which usually those are the kind of models that you use in computer vision, and do all the fancy computer vision explanations there.
And you're referring specifically to 4.6, right?
Yeah, 4.6,
okay,
correct. Yeah. So we are now looking at a way for anyone to be able to create those nodes and share them on KNIME. For now, we are still like in its earlier release, but it's really exciting, right? Because we already have many components, many nodes in KNIME. But if we're able to tap all the potential that is in the Python ecosystem, then even more nodes are going to appear for, yes, computer vision too, and XAI there. Yeah.
I have a very quick one for Suman, and then I'm going to switch back to slides because I want people to know how to stay in touch with me and where they can find like the longer course and everything. So Suman, your question was, why do you have to change the accuracy of the surrogate model? I didn't manipulate the accuracy. What I did is I chose accuracy in the report. The default is F-test, and I just thought for my presentation. So it's the accuracy in this case is how well does the surrogate match the original? That's not the default statistic that's calculated. The default statistic that's calculated in the view is an F-test, and I just went with accuracy. So I didn't manipulate the accuracy. I simply chose that to be included in the report. So what I'm going to do is go back to slides here.
Just something, there is one question that is really good by Stefan Plotz. I've never worked with KNIME, he says. Can you put the local prediction node into production with solid performance or get outputs for further processing units? The answer is yes, that's come usually with the KNIME server. That's when you add the commercial offering to KNIME, to the KNIME Analytics Platform, which is the open source and free version of KNIME. And you can move this UI into a server so that people can access it simply via a web browser. And Keith didn't go too much into the basically deployment part, but I think this is a good point, right? It's great to open those workflows, pull in components, open interactive view, and understand things, but it's also great to offer those interactive views to someone that doesn't want to do anything to do with nodes, component, connections, KNIME Analytics Platform. He only wants to see that view on a web browser on fresh new data, right? So that's possible, comes with KNIME Server, KNIME Web Portal, and those basically deploying workflows as data apps, right?
Yeah, no, agreed. It's a big topic. That's one of the reasons that I issued that disclaimer at the very beginning, was to emphasize that it is important, but just didn't fit, our time today. So a couple of quick comments, and then we'll wrap up, and I'll let you guys decide if we can close on one more question or one more comment or how we do that. But I'm easy to find on LinkedIn. I'm one of those folks that got lucky, and I don't have, it's not like Keith McCormick and a bunch of characters and names after my name. It's just LinkedIn Keith McCormick. And I'm very active on that platform because I have the LinkedIn Learning courses. So one of the things that I encourage you to do is when you go to LinkedIn Learning, you can certainly search for KNIME, and I encourage you to do that. But if you're curious about what courses I've taught, you can search by instructor, and we all have a page. So I actually have, believe it or not, my 19th one comes out in 2 days. I've been quite active on that platform since 2016. And also make note of this. Every first Friday of the month, I post a class to my feed, and what I'm going to do is I'm going to post my data assessment class because it has a lot of KNIME content. It really is a KNIME class. So that's that Data Science Foundation's data assessment for predictive modeling. It's about 4 hours. It's really in depth. It's the data understanding phase of ChrisDM, and I'm going to make that my free first Fridays in 2 weeks' time. So just kind of make a note. I mean, if you follow my feed, you'll see it. But that makes the course free for 24 hours or something like that. And then I have 5 KNIME courses in the library at this point, although one of them is being updated for KNIME and will come out the end of this year. So Paolo, as you know, I'm always reaching out to you about once a month to know, ooh, what's brand new that I should make sure it gets into the class.
Yeah, keep reaching out. So we keep on putting all our shiny new stuff in your amazing courses. Thank you, Keith. Absolutely. Yes. So I think we reached the end. There are, of course, more questions. There was Skalk saying thank you, Peter Boreas saying thank you. But basically, yes, I think that answering all those questions now, maybe they can also find you on LinkedIn, right? And and contact you directly.
Yeah, will KNIME be posting this? You know what just occurred to me is I didn't think. Okay, so now I'm scrambling to get this done while folks are still on. But if I can manage to do it quick enough, I think what I'll do is post to the chat the LinkedIn announcement that I used to say I was going to do the talk, and I can actually take more questions right there. If you follow what I'm suggesting, is we can use the quick little video that I did to say in 24 hours I'm gonna do this talk. I can actually put that in the chat, and people can post questions below that, unless there's another KNIME post that would be a useful way to do that.
Let's do like that. So we're gonna send a follow-up email with the slides, right? And
oh, great. Okay.
And then in there we can put a link, right? And they will be able to reach out to you, maybe a point of contact, right? And possibly also link to your courses, and then from there they will actually find everything.
That's going to work great. So this is what I'm going to suggest. Okay, everybody, what's going to happen is Paolo's going to prepare that to go out. We'll announce it as like a thank you for coming, and the thank you for coming will push out that information. But also, I'll make a point to monitor the questions, the comments that might appear below that in my LinkedIn feed. So perfect. if you follow me on LinkedIn, at some point that post will show up, and we can and I'll mention right in the post that would be a great way to do Q&A.
Perfect. Okay. All right. Thank you then. And then, yeah, see you on LinkedIn, people, or wherever else. And thank you for joining us. Bye.
Yeah. Thanks, everybody.
Thank you, Keith.